Hi children, hope you are doing great. Welcome to Electron Chemistry Center, abbreviated as ECC. Now in today's lecture we are going to discuss about, we are going to start a new chapter called Chemical Kinetics. It is a physical chemistry topic of grade 12 and it is very important topic for NEET as well as for IIT. Now we are going to discuss about chemical kinetics. What is exactly chemical kinetics? It is a branch of physical chemistry. The branch of physical chemistry deals with rates of reactions. If you consider a particular reaction, with how much speed the reaction can occur, that is nothing but rate. And with how much speed a reaction can occur, how this reaction can occur, all these will be discussed in chemical kinetics. We have learnt in thermodynamics in grade 11, thermodynamics could explain about feasibility of a reaction or spontaneity of a reaction, but it could not explain with how much speed a reaction can occur. That drawback can overcome by the help of chemical kinetics. So we are now starting with a term called rate of reaction. Rate of reaction, I am giving it as R. Right? So what is exactly meant by rate of reaction? R is equal to change in concentration of reactants or products. Change in concentration of reactants or products with respect to time is called rate of reaction. For suppose if you consider a reaction, A is giving rise to B. A is considered to be an example of a reactant and B considered as products. Whenever A is involved in chemical reaction, A starts to decompose. What does it mean? Concentration or amount of the A decreases. At the same time, concentration or amount of B increases. So that can be given as a change in concentration. Let us say initially you have taken 1 molar concentration of a reactant. After some time 1 molar can become 0.5 molar. So with respect to time, how much change in concentration of reactant as well as a product will be given as a rate. So here rate of disappearance of A, that is reactant, is equal to rate of appearance of B. Rate of appearance of B. How much amount of or how much concentration of A is decreasing, same amount of the product will be formed. It will be given as a rate of disappearance of A is equal to rate of appearance of B. Now this rate formula, if you write it in a mathematical expression, change can be given as delta. So C represents for concentration, change in concentration with respect to time, it will be given as delta C by delta T. Or else you can write it as C2 minus C1 divided by T2 minus T1. It is final concentration, it is initial concentration. T2, it is the final time and T1 is the initial time before starting the reaction. Now what are the units can be given for rate of reaction? Concentration is the numerator term. So concentration, what are the units? Mole per liter upon time interval is there. So it is second. It can be written as mole per liter per second or mole liter inverse second inverse. Or else you can write mole liter inverse minute inverse. Time units may changes. Remaining this concentration units remains same. Mole per liter will be same. Minute inverse you can write it. R inverse you can write it. day inverse you can write it, year inverse can be written. Any one of the unit can be given. Mole liter inverse, minute inverse, mole liter inverse, hour inverse, mole liter inverse, day inverse, mole liter inverse, year inverse. Those are the units of rate of reaction. Hope you understand what is exactly rate of reaction, right? So rate is nothing but change in concentration of reactants or products with respect to time, right? Now, based on this rate of reaction, based on rate of reaction, chemical reactions are classified into three types. With how much speed they will occur, based on that chemical reactions are classified into three types. First reactions are fast reactions. Fast reactions in which what will happen? Reactions can be completed. Reactions can be completed in seconds. If reactions completed in seconds, within a fraction of seconds, if reactions are completed, in such cases those reactions are called fast reactions. For fast reactions, time interval is small, delta T is small. As you know, rate is delta C by delta T. So rate is inversely proportional to time interval. If time interval is small, rate of reaction is larger. For such type of reactions, we cannot study kinetics of those reactions because rate of reaction is higher. Now, what are the best examples of fast reactions? Ionic reactions are examples of fast reactions. Why? Because in ionic reactions, there is no breaking of bonds. Because of that, ionic reactions are considered to be examples of fast reactions. Let us take one example here, AgNO3 plus NaCl giving rise to AgCl plus NaNO3. AgNO3, it can be existing as plus and minus, it will be plus and minus. This plus interacts with minus, minus interacts with plus. This type of ion exchange is taking place. This reaction will take place within a fraction of seconds. Hence, these reactions are called fast reactions. Second type of reactions, if you observe it, slow reactions. Slow reactions in the sense delta T is large. It takes long time. It takes long time to occur. Such type of reactions are said to be slow reactions. So what you will write here, reactions can be completed in days or years. If reactions are completed in days or years, such type of reactions are said to be slow reactions. In that cases, delta T will be taken as large, rate of reaction will be smaller. As I told you, rate is delta C by delta T. Rate is inversely proportional to delta T. If delta T is larger, rate will be smaller. For those reactions also, we cannot study kinetics, right? So, for the best example of slow reactions is rusting of iron. Rusting of iron is an example for that. Now, let us see third type of reactions, which are called moderate reactions. Right? Moderate reactions are intermediate between fast reactions as well as slow reactions. These moderate reactions are neither too fast nor too slow. So what you can say, reactions can be completed. Reactions can be completed in hours, or else you can say in minutes. If reactions are completing within minutes or hours, such type of reactions are called as moderate reactions. Example, let us take digestion of food. It is the best example for moderate reaction, which can be completed within 4 to 6 hours. Similarly, decomposition of hydrogen peroxide. Decomposition of hydrogen peroxide. These two are examples of moderate reactions. So, moderate reactions, delta T is optimal, moderate. These type of reactions can be studied under chemical kinetics, but not slow reactions, too slow reactions, not too fast reactions, right? Moderate reactions can be easily studied under kinetics. So now, so far we have learned about what is rate of reaction. Based on rate of reaction, what type of reactions are there? We do have fast reactions, slow reactions and moderate reactions. Okay. Now, let us discuss about types of rates of reactions. Types of rates of reactions. There are majorly two types of reactions, rates of reactions. One is average rate of reaction. One is average rate of reaction. And second one is instantaneous rate of reaction. Second one is instantaneous rate of reaction. Here let us start with the average rate of reaction. Average rate of reaction is nothing but rate of reaction measured over long time period. Rate of reaction measured over long time period is called average rate of reaction. Sometimes you may get the question, define average rate of reaction. What do you write? Rate of reaction measured over long time period. So here in long time period, if you want to measure, in such cases you will take two time intervals, initial time and final time. In that cases you will take average rate of reaction. So how you will give average rate of reaction? R average is equal to, if I write an example for the reaction, that is A is giving rise to B. So R average rate of reaction is equal to minus delta A by delta T. So it is with respect to reactant. Now if we write with respect to products, average rate of reaction with respect to product, what you will write? Plus delta A upon delta T. Delta represents for large changes. Whenever there is a long time period or large time period, then only we will use average rate of reaction or delta. It is square brackets represents for concentration. It is change in concentration of reactant and it is change in concentration of product. So it is delta B. Here minus negative sign signifies decrease in concentration. Concentration of reactant decreases. At the same time, concentration of product increases. That's why we are giving plus sign. So plus sign signifies increase in. Concentration. Here negative sign signifies for decrease in concentration of reactants. Whereas positive sign signifies increase in concentration of products. Did you understand? Whenever if they write minus stands for decrease in concentration. Plus stands for increase in concentration. Right? The same thing it can be written as delta A. So minus A2 minus A1 upon delta T, it will be written as T2 minus T. Similarly delta B plus B2 minus B1 upon T2 minus A2 is the final concentration of A. A1 is the initial concentration of A. T2 is the final time and T1 is the initial time. Similarly, B2 and B1 are final and initial concentrations of B respectively. Let us take A initially is having 1 molar. After some time it has been changed to 0.5 molar. Then what do you get? 0.5 minus 1 upon. Let us take this time interval, they have taken it as 10 seconds. T2 minus T1 is equal to 10 seconds, let us consider. Then what do you get? 0.5 minus 1 you get minus 0.5. That means finally what do you get? 0.5 by 10. You will get plus only here. 0.5 by 10. What does it mean? Rate of reaction is always positive. It will never be negative. We will never take average rate of reaction or any type of rate of reaction. We will never take it as negative. This rate of reaction is always will be taken as a positive. Right? Now, let us see for reactants as well as products. How you will write or how you will draw graph based on by using average rate of reaction. How you will give average rate of reaction? First, for reactants, as well as I'll give you here even for products also. For reactants, if we take here, reactant is concentration. How concentration of reactant, A is the reactant, with respect to time, how concentration of reactant changes. Initially reactant concentration is very high. Now when reaction starts, as time goes on, reaction is proceeding, reactant concentration decreases. Right? So initial concentration of A, let us take here, this concentration is A1 with respect to time interval T1. Similarly, after some time, let us take here time T2 and the concentration becomes A2. The difference in these two concentrations can be taken as delta A. Similarly, the difference in these two time intervals will be taken as delta T. In such cases, R average is given as minus. As I already told you, minus stands for decrease in concentration of the reactant. Delta A upon delta T. This is the graph will be given for reactants. Whenever average rate of reaction is given, we have to use delta. When it comes to products, how we will write or how we will draw rate of reaction graph. Let us make a look on it. It is concentration of B taken on y-axis, time is taken on x-axis. Right? B concentration is taken on y-axis. That is product concentration. So initially product concentration is very less, or else you can take it as 0. As reaction started, time goes on, reaction is proceeding, product concentration slowly increases. Right? So initially concentration of product is very less. With respect to this time T1, I can take it initial concentration as B1 of product. As time goes on, as reaction is proceeding, with respect to this T2, right? This product concentration is taken as B2. So now the difference in these two concentrations of products will be taken as delta B. This is the change in concentration. Now the difference in the two time intervals will be taken as delta T. So what you will write here, R average is equal to plus signifies increase in the concentration of the product, plus delta B upon delta T. It is increase in concentration of the products, that is plus indicates. So change in concentration of the products with respect to time will be given as average rate of reaction. This graph is for reactants, this graph is for products. Whenever delta is given, you have to take average rate of reaction. Right? It is the first type of rate of reaction. Hope you understand. Right? Now let's make a look on it. Second type of rate of reaction. What is that? Instantaneous rate of reaction. Instantaneous rate of reaction, name indicates clearly. For suppose if you want to calculate rate at every instant of time, initially time, let us say before starting the reaction to the next second, like 1 second, what is the rate change or what is the concentration change? For 2 seconds, what is the concentration change? For 3 seconds, what is the concentration change? For every second of time or for every instant, if you want to measure how much change in concentration is there, that will be given with the help of instantaneous rate of reaction. So instantaneous rate of reaction means rate of reaction measured over infinitesimally small time. If rate of reaction measured over infinitesimally small time, such type of rate of reactions are said to be instantaneous. For instantaneous rate of reaction, I am using RINST, R instantaneous, right? So now, when delta T tends to be 0, in such cases, R average becomes R instantaneous. So, R instantaneous, I am taking a reaction, A is giving rise to B. R instantaneous is equal to decrease in concentration of reactants, but here what you will represent? D you will represent. Whenever change is large, we will represent delta. Whenever change is small, we will represent D. So, D of A upon dt. It is for reactants. But suppose if you want to write it down the rate of reaction with respect to product, that is B, then what will you write? Plus dB upon dt. This is instantaneous rate of reaction with respect to product. This is instantaneous rate of reaction with respect to reactant. Right. Whenever delta is given, what you will write? Average rate of reaction. Whenever D is given, what you will write? Instantaneous rate of reaction. For suppose if they ask you to find rate of reaction in any numerical, that means it is instantaneous rate of reaction only. Until and unless if they mentioned average rate of reaction, you are not supposed to take average rate of reaction. If they have not mentioned anything, simply they have mentioned rate of reaction, you have to consider instantaneous rate of reaction only. This is the expression for rate with respect to reactant, with respect to product. Now, you will see the graphical representation. How you will see the graphical representation? Let's make a look on it. First for reactants. For reactants, what you will give? So I told you A is giving rise to products. A is the reactant. With respect to time, time is taken on x-axis. Concentration of A is taken on y-axis. Right. So initially concentration of A is very high. As reaction proceeds, concentration decreases. Concentration decreases. So initial concentration I am taking it as A1. With respect to time, T1. But as reaction goes on, right, concentration decreases, A2, it becomes A2. With respect to time, T2. The difference in these two concentrations will be taken as dA. Earlier I have given you delta A, but now here dA. With respect to time change, it will be given as dt. So R instantaneous is equal to minus decrease in concentration of the reactants dA upon dt. So this is the instantaneous rate expression. When it comes to products, as it is same whatever I have given earlier, but here time interval will become dt, here concentration will become dV. Then R instantaneous rate of reaction is equal to plus dV upon dt. Plus indicates for increase in concentration of the products, here it is change in concentration of B upon dt. Right? It is the graph given for reactants and it is the graph given for products. This is the way how to draw the graph for average rate of reaction as well as for instantaneous rate of reaction. Right. Hope you understand, children. So far we have discussed what is rate of reaction. Right. Based on rate of reactions, there are three types of chemical reactions: fast, slow as well as moderate reactions. And there are two types of rates of reactions: average rate of reaction. Second type is instantaneous rate of reaction. Now we will be discussing about rate expression for a reaction. For a reaction, how you will express the rate. So far, I have given you rate, how to express the rate with respect to a reactant as well as with respect to product. Now, how you will write the rate expression for a whole reaction? For a whole reaction, how you will write it, that I am discussing now. Let us consider one example here. Let us take one example, N2 plus 3H2 giving rise to NH3. Now I am taking stoichiometric coefficient. Stoichiometric coefficient, I am writing it as SC. For nitrogen it will be 1 mole of N2. How many moles of ammonia, children? 3 moles. And it will give you 2 moles of ammonia. This is stoichiometric coefficient of nitrogen. It is stoichiometric coefficient of hydrogen. It is for ammonia. Let us consider if nitrogen concentration is X mole per liter. If it is X mole per liter, then hydrogen concentration will be equal to 3x mole per liter. Will be equal to 3x mole per liter. Similarly, ammonia concentration will be equal to 2x mole per liter. Will be equal to 2x mole per liter. Now, if we write the rate expression, right? Then what you will write? With respect to nitrogen, I will write minus dN2 upon dt, which is equal to, with respect to hydrogen, minus, so minus dHT by dt, right? Which is equal to plus dNH3 by dt. Now, how can I make this rate of reaction with respect to nitrogen equal to rate of reaction with respect to hydrogen as well as with respect to ammonia? So, if I take, this is X, the concentration is X, but this concentration is 2X. If I divide with 1, you will get X. If I divide with 2, it will be, sorry, if I divide with 3, because 3X by 3, it will be equal to concentration of N2. Its concentration is 2x. If I divide with 2, it will be equal to x. So, while you are writing rate expression for a particular reaction, what you have to do? Change in concentration with respect to reactants and products will be divided by stoichiometric coefficient. Here 1 is the stoichiometric coefficient of nitrogen, 3 is the stoichiometric coefficient of hydrogen, 2 is the stoichiometric coefficient of ammonia. Similarly, you can take one more example here, H2 plus I2 giving rise to 2HI. How you will write the rate expression? Rate is equal to minus dH2 by dt upon 1. Stoichiometric coefficient is 1, is equal to minus di2 upon dt upon 1 is equal to plus 2 is there, plus dhi upon dt upon 2. Here stoichiometric coefficient is 2. Similarly, if you take one more example, 2CO plus O2 giving rise to 2CO. What is the rate expression? How you will write the rate expression? Minus dCO upon dt upon 2 stoichiometric coefficient, which is equal to minus dO2 upon dt upon 1. It is the stoichiometric coefficient. Is equal to plus dCO2 upon dt upon 2. This is the way of writing rate of reaction, a rate expression for a particular reaction. And you have to remember that rate reaction is defined only for balanced equations. Equation must be balanced. Then only you can give rate expression for a particular reaction. Okay. So now we come to know how do you write rate with respect to reactant as well as with respect to product, and rate of a reaction with respect to reaction also, for all reaction also. Let's solve few numericals. Here what I'll give, if rate of disappearance of hydrogen, if rate of disappearance of hydrogen is 12 mole liter inverse second inverse in N2 plus 3H2 giving rise to 2NH3. In this equation, rate of disappearance is 12 mole liter inverse second inverse. Now, what is the question given to you? Find rate of disappearance of nitrogen. Find rate of disappearance of nitrogen, as well as find rate of appearance, or else you can say formation of ammonia. Part C, find rate of reaction. What he is asking? Yes, he is asking you to calculate rate with respect to nitrogen, with respect to ammonia, as well as he is asking rate of whole reaction. Now if we come to the solution, how do you solve? First write down the rate expression. What is the rate expression? Minus dN2 upon dt divided by stoichiometric coefficient minus dH2 by dt upon 3 is equal to plus dNH3 upon dt upon 2. This is the rate expression can be given for the reaction. Now they are given rate of disappearance of hydrogen. They are asking you to calculate rate of disappearance of nitrogen. First we are calculating part A. Part A, if you see, in this rate of disappearance of nitrogen is equal to rate of disappearance of hydrogen. This part you don't know. dN2 by dt you don't know. Let us say it is x divided by 1 is equal to dH2 by dt, they have given 12 upon 3. So x is equal to 4 mole liter inverse second inverse. This is the value what we got for rate of disappearance of nitrogen. Now when it comes to rate of appearance of ammonia, rate of appearance of ammonia, how you will take it? dH2 by dt upon 3 is equal to plus dNH3 by dt upon 2. This value you know, how much? 12 upon 3. This value you don't know. Put the question mark upon 2. 2 into 12, 24 upon 3, what will you get it? X, that is 8 mole liter inverse second inverse. This is the value for rate of appearance of ammonia. Now we will calculate rate of reaction. Rate of reaction, how do you calculate? Rate of reaction means with respect to all reagents, both reactants as well as products. dN2 by d2 is how much we got it? 4. 4 upon 1, it will be equal to 4. With respect to hydrogen, 12 by 3, it is 4. With respect to ammonia, 8 by 2, so 4. So overall rate of reaction is 4 mole liter inverse second inverse. Okay, this is the way how to calculate if they have given rate of disappearance of any of the reactant. If they give rate of appearance of product also, you can calculate rate of reaction as well as rate of disappearance of other reactants. Now I will change the same question. Hope you copied this question, right? Now in second question I am giving you another question. If rate of disappearance of hydrogen is 12 mole liter inverse second inverse in 2N2 6H2 giving rise to 4NH3. I am changing the stoichiometric coefficients. So find rate of disappearance of N2, find rate of appearance of ammonia and rate of reaction. Rate expression will change. So rate expression, what will happen? Minus dN2 by d2 upon 2 minus dH2 by dt upon 6. Here stoichiometric coefficient is 4 for this particular reaction. Now what you have to calculate? First, part A, we have to calculate rate of disappearance of N2. So you don't know this. X upon 2 is equal to 12 by 6. So 2 into 12, 24 upon 6, what do you got? 4 mole liter inverse second inverse. That is rate of disappearance of N2. Now what you are calculating? Rate of appearance of ammonia you are calculating. This value they have given, that is 12, but stoichiometric coefficient is 6, but here stoichiometric coefficient is 4. 12 upon 6, this value you don't know, upon 4. What will you get? 4 into 12, 48. Upon 6 will give you 8 mole liter inverse second inverse. Now finally what you have to calculate? Rate of reaction. Rate of reaction with respect to all reagents, reactant as well as product. dN2 by d2 value, how much we got? 4. 4 by 2, 2. It is 12. 12 by 6, 2. And it is what we got? 8. 8 by 4, 2. That means what we got? Rate of reaction is equal to 2 mole liter inverse second inverse. Right? This is the rate of reaction. If you observe, when it is compared to previous example, every data is same. But I have changed only stoichiometric coefficients. If we change stoichiometric coefficients, what will happen? This rate of disappearance, appearance will not change. That is same. But what will change? Rate of reaction has been changed. Earlier we got answer 4 mole liter inverse second inverse. But here what do we got it? 2 mole liter inverse second inverse. That means if stoichiometric coefficient changes, rate of reaction changes in this reaction. Right. Now another way of asking question. Right. Question number 3. Third question we are solving. If rate of disappearance of hydrogen is, I am changing this question, 6 gram liter inverse second inverse in N2 plus 3H2 giving rise to 2NH3. In this reaction, rate of disappearance of hydrogen is given, but not in mole liter inverse second inverse. They have given in gram liter inverse second inverse. What is asking you to calculate? Find rate of disappearance of nitrogen as well as find rate of appearance of ammonia and rate of reaction. Expression, how you will write? dNt by dt, stoichiometric coefficient is 1, for hydrogen stoichiometric coefficient is 3, for ammonia stoichiometric coefficient is 2. So before doing this, whatever the given data, right? The given data is, what is the given data to you? dH2 upon dt is equal to 6 gram liter inverse second inverse. You have to convert this into moles. Mass is given, so divided with molar mass. That is, molar mass is 2 grams per hydrogen. Then what you will get? It will be converted into mole. You will get 3 mole liter inverse second inverse. It is a previously year JEE asked question. Right? In JEE, in previous year this question has given. Same data as given, they have asked rate of reaction. Now we have converted grams into moles first, then only you have to do. You are not supposed to solve with gram liter inverse second inverse. Once if you have converted into 3 mole liter inverse second inverse, then part A, what is rate of, what is in part A is asking rate of disappearance of N2. What is the relation? I'll take dN2 by dt upon 1. This you don't know. That is x upon 1 is equal to dH2 by dt. What is the value got it? 3 upon 3. So finally what you got it? X is equal to 1 mole liter inverse second inverse. This X is rate of disappearance of nitrogen. For suppose if they ask you to convert this mole into grams, so 1 mole of nitrogen in the sense what you can take? 28 gram liter inverse second inverse you can take it. Okay. Similarly, part B, what is asking children? Rate of appearance of ammonia. Rate of appearance of ammonia, what you will take it? Minus GH2 by dt is 3. 3 by 3 is equal to, this you have to calculate, that you don't know. Question mark upon 2. So then what will you get it? 3 by 3, that is 1, is equal to 2. So what will you get it? dNH3 upon dt is equal to 2 mole liter inverse second inverse. If they ask you to express the same value in grams, then what you will do? 2 moles in the sense 34 gram liter inverse second inverse. 1 mole of ammonia is 17 grams, no? 2 moles 34 grams liter inverse second inverse. Finally, what you have to calculate? Rate of reaction. So part C I am doing here. dN2 by dt. How much you got? 1 by 1. That is 1. dH2 by dt value is how much? 3. 3 by 3. That is also 1. Here what you got? 2. 2 by 2. 1. So rate of reaction is equal to, what is the value got it children? Rate of reaction is equal to 1 mole liter inverse second inverse. Is that clear? So this is the way how to ask. So far we have done rate of reaction with respect to reactant and product if they have given in mole liter inverse second inverse. Second numerical, what we have done if they change stoichiometric coefficients. Third one, what we have done if they have given in gram liter inverse second inverse, you have to convert into moles, right? So finally what you got it? Rate of reaction. Right? Copy it.